Okay.
Are we live?
Not yet. Okay.
All right.
Okay. Something is happening. Okay. I
Are things up?
think we're live. Okay, we're live.
Yay.
So yeah, sorry for the delay. We had some technical issues,
Hold now.
but we are live now. So thank you everyone for coming for this last event of the GDC Valladolid. We have brought a good speaker for this last talk. So let me introduce you to Jorge Galván Lobo, industrial and aerospace engineer, engineering aerospace projects with Alten Toulouse. Well, I think he will introduce himself later. So just thank you for this talk, Jorge, and you're up. So
Sure thing. So first of all, thank you, Pablo, for inviting me to talk today. It's a true pleasure and an honor. So yeah, so today we're gonna talk about a new space. Perhaps some of you may have heard of this before. It's kind of starting to pop around in normal conversation, I think. And perhaps you were wondering what's actually new space, and given that it's a really open subject, perhaps you're even thinking of, hey, could be my spot. So let's talk about what new space is and what it can offer to you. But before we do, let me just really quickly introduce myself. As Pablo said, I'm an industrial engineer from Valladolid. I actually studied at the University of Valladolid. I did industrial engineering there. I then went on to get an aerospace engineering master's at ESA at Toulouse, which is where I reside actually. And I actually majored in space systems, which technically makes me a space engineer. I've been involved in different projects in collaboration, especially with ESA, with the European Space Agency, but also with CANES, particularly one called Artemis Microgravity, which went to the International Space Station a couple months ago, and some others that are still in development, like Scampi, which is scheduled to go to the ISS in the coming years. And I've been the founder of a team here at Toulouse called Students in Microgravity, which aims at developing these kind of projects. And finally, I'm a mechanical engineer for a nonprofit organization called Spring Institute for Forests in the Moon, which aims at putting a forest in the moon in the far future, but currently works in biotech for space. And finally, I am also an engineer for aerospace projects with Alten Toulouse, which is a company that can be found in many cities, but one of them is Toulouse. But beyond who I am, let's talk about the subject matter, which is new space. So many people have heard about new space, but may be wondering, what are we talking about here? Well, when we talk about new space, we're talking about the shift in paradigm that has happened in the past 15 years, more or less, in how we perceive and act in space as a whole. Basically, in the past, we act in a very particular manner, especially in terms of who had access to space and with what objectives, in regards to how we do it now, today. This most important aspect of new space is the explosive growth it's caused in the space sector, given that it has given access to so many new people and so many new companies, ideas, and different initiatives into the space sector's field. And this has caused that it's come from basically an exploration field into a truly commercial field. And that shift has brought an exponential growth to the sector in many senses. Moreover, it has brought a shift in how we perceive it from a societal and cultural level. Space has shifted in its shape, let's say, on how we act on it and how we perceive it from a normal day life, from being something that is basically administered by agencies and basically big companies normally working with or for the government. And it's gone into a more democratized system where the private sector actually has a big role to play, and where research that isn't doesn't have to be basically linked to those big agencies can be done, and where small companies can actually thrive if they have the aim and the drive that they need. But beyond this broad strokes we've given, let's first see where we come from. So basically, the space sector is it's born basically in the Cold War, during what we call the space race. Before that, we did have some missile and rocketry investigation being done, especially during the Second World War. But to be honest, the space sector was born during the Cold War for a very particular reason, which was a space race. The space race was a political confrontation, really, between the USA and the capitalist bloc versus the Soviet bloc. And what happened here is that they both wanted to go to space, primarily to get there first. This means that there wasn't a technical objective behind the space race in earnest. The objective was to get there first, and then we would see what we'll find. This caused that the kind of projects that we aimed at doing during those times were very ambitious, but didn't have a technical or scientific aim as its biggest priority. One of the most important aspects of this space race and what came after it is that the only ones really capable of developing the technology and having the capital to reach space were the big public national agencies like NASA, or at some point different KNES, the Soviet, we also have the Soviet Space Agency, but in general, it was basically big agencies dominated by basically their countries that were aiming at reaching those political goals. This also in turn caused very big projects like the Apollo missions with the Saturn rockets. We're talking about huge technology, huge capital being used and expended in these projects with not a commercial target behind it. One of the most important aspects here is that access to space was limited to a very small number of countries. It wasn't even the fact that the private companies couldn't access space. There was many countries as a whole that couldn't access space. It was basically USA, France, and the URSS for a very long time. It was almost in the 80s that we start seeing more and more countries, and even then we're basically entering the 2000s. We're still talking somewhere in the midst of 12 countries, perhaps, that were able to launch to space on their own. And one of the important things here is that this means that there is not easy access to space for many people in the world. If they want to get to space, they have to go through the agencies of these countries that have basically space access. They have the means to reach orbit. And that really filters a lot what kind of projects can get through. And one of the important things here, as I mentioned, is that the aim for a very long time stays being either exploration or perhaps commercial technology, but with a truly national interest in mind. So, for example, GPS, yes, it has some commercial importance, but in general, it's for the whole nation to enjoy. It's not a commercial product that can be really produced in mass. So the shift really comes when the space sector as a whole changes these three aspects and some other into the ones we see in the right. So the aim goes from being exploration mainly to exploitation. This is, we're no longer trying to just explore and get there just because, but now it becomes, okay, let's go to space and let's try to make a profit out of it. Let's try to make this into a business we can basically scale, that we can profit from, and that we can grow with time. One of the very important aspects as well is agencies basically transfer many of their missions and objectives to the private sector. Agencies are still important, and we'll see that in some of the coming slides. But private sector really takes the kind of the leading voice in new space, where they make use of the agencies as the support and kind of their guide, and also perhaps the science support behind many of the actions of the private sector. But it's really private sector driving the the industry and the sector towards new goals and new launches and new companies and new technology. This can be seen perhaps with companies like SpaceX, that has become quite a household name, where basically a completely private company reaches a status of acceptance in the space sector, where they're basically working as a de facto launcher for many of the missions of ESA, NASA, and some others, where they're trusted as a launcher, but they're completely private. This in turn means that their aims and the way they fabricate, the way they construct their company and their products is aimed at making a profit, not just completing their goal. And thus makes an important drive towards reducing costs and making things scalable, and basically allowing for serial manufacturing, which is one of the ways that you can turn sector from somewhere that is research into something that is commercial. We'll also talk about reusable launchers in the coming slides. Finally, the kind of capital involved is shifting with this new space. We're no longer aiming at doing high capital, enormous projects with enormous goals in mind. That was the aim during those first years with the space race, where we were saying we're going to the moon. Costs don't matter that much. Let's just get there. Now we're aiming at something that we can actually afford, in the sense of, if we put this amount of money in, there will be a profit. In terms of profit, missions like Apollo 11 weren't really profitable as an independent project. There may be some other impacts that were remarkable, but in the sense of the mission, there was no return. With new space, projects made by the private sector will want a profitable return, and this in turn makes that the kind of technology developed at the moment is small scale. We're aiming at smaller technology that is normally reusable, easy to manufacture, and completes the goal in the smallest, using the smallest amount of capital possible. One of the most important changes that new space uses really is the shift, let's say, a bit in space law, and how the perception of how space should be treated has changed with the years. One of the most important space laws in the world is the Outer Space Treaty. This is a treaty that most of the countries in the world, and especially those with space access, actually abide by. Is the Outer Space Treaty, which is quoted here. It's not the whole thing, but mainly comes to say that in space there is no really countries. Everyone should collaborate, especially when there's dangers, and there shouldn't be any kind of militaristic use of space, and that space is a place for exploration, that there is no, as it says here, occupation, sovereignty, or any other kind of claim over things that are South Earth. That is to say, no matter if you plant a flag in the moon is not yours. This is a very important concept, because once we arrive at exploitation of space, then the question becomes, are the resources you're exploiting, especially if we eventually arrive at using asteroids and those kind of resources, mining the moon, mining Mars, etc., that is a bit futuristic, but will arrive at some point. We have to be very clear as to what is someone's property or not. So that is actually, the Outer Space Treaty kind of leaves exploitation up for grabs, in a sense, where it's not really defined. But with the Artemis Accords, which are a series of accords signed by many of the countries currently pushing for the moon and Mars and some of the other places in our solar system currently. One of the things they agree on is a couple lines on exploitation. It's actually a couple of the accords treat this matter extensively, where they basically saying you cannot own places on space, but you can own the rights for exploitation. That is to say, you can basically make use of resources you find on space. You just cannot claim that that piece of land, that the place where you're exploiting, is actually yours. Is this enough to make this survive when actual money starts flowing in from, for example, mining other celestial bodies? We'll see. But at least there's an effort from countries to put some legislation in place, because they're seeing that new space is arriving, private sector is arriving, and they'll need it at some point in the near future. But beyond these law changes, there are still many challenges that have to be addressed, that have only become clear with the arrival of all these companies to the space sector. One of the most important ones is orbital debris. For a long time, there was not many people launching things into space. So the orbital debris we had wasn't a big concern. But in the past years, we are seeing increments that are truly exponential in the amount of launches, the kind of the sizes of things being launched. The smaller something is when it's launched to space, the more difficult it is to track. That means that it's more difficult to predict where it will be, and then it becomes more difficult to prevent it from hitting something else. This in turn makes the issue with debris even worse. Right now, we have a true problem where debris is starting to build up. For a moment, it's not banging against mostly anything. But if it gets truly bad, then we will have to wait for everything to fall onto Earth, and that could be centuries. So one of the biggest issues right now in new space in general, and it's one of the things that the agencies are spearheading, is finding a solution to orbital debris, which will make space scalable. Right now, if we truly get space to scale, we'll fill it up with debris quite quickly. And that can be a true problem. That is one of the reasons, that is one of the things we're trying to fix in new space at the moment. One of the other things is broadband management. Because right now, a lot of people are sending satellites or nanosatellites to space. This means there's more objects competing for the same broadband of telecom, which hasn't really grown in the past years. It won't grow ever. This will mean that we have to be very careful on what we assign to each of these satellites, so that they can communicate effectively with Earth. So one of the biggest issues right now is getting everyone on the same page on how to communicate with all the technology we're sending to space, so that there's as little interference as possible. One of the other issues is that one of the biggest agents in the space economy right now, which is the geo satellite demand, this is the big satellites being created by Airbus and other Thales Aliena and some of the other big companies that have been working in space for many years. These are true monsters of satellites, cost hundreds of millions to be put in place, and they normally control most of the big telecoms for whole countries, TV, those kind of technologies. They're needed, but it's becoming more expensive with time, and it's the demand for that kind of satellites is decreasing, which means that some of the capital going in is not flowing as much as it used to. So trying to find some other way of finding capital is becoming increasingly important. Finally, with all these small satellites being launched, as we'll see in a bit, we're seeing a lot of objects in space having different orbits, and managing who is in what height is very important. Because if there's not some kind of management of those orbits, if the different companies involved are not talking with each other or are managed by some kind of institution, it's very possible at some point there will start being collisions between the different things in space. New space brings a lot of things. There's a lot of launches, a lot of satellites being placed, which means it becomes very, very complex to know where everything is. And as I said, if things start banging against each other, there will be even more orbital debris. So there is truly some issues right now with the fact that we are shifting very quickly into a exploitation model, really private sector, a private space, basically, where we're not truly ready, because up to now it was a very select club of agencies and companies that were able to go to space, and now it's almost everyone. And that shift it requires that we shift how we think and how people communicate. In the past, everyone knew who was sending what, so it was easy to communicate. Now it's way more difficult to track. So keeping all these 4 challenges in mind is crucial if we are to succeed in effectively developing this new space. I've talked a bit about the new technologies, but we should really go into it a bit more. There's basically 3 big aspects that we have to consider here. The first one would be nanosatellites. The thing here is that for a long time, satellites were big objects being sent into geo orbit, normally, which is a very orbit really far away from Earth. And these are machines that cost hundreds of millions, as I mentioned. Nanosatellites, on the contrary, we're talking about objects as big as perhaps a couple meters, and that can be manufactured for a low price. They can perform their normally Earth observation duties as well as telecom duties quite effectively. And this means that the launch cost is quite reduced in terms of the technological cost of the payload. And this implies that many people can launch this kind of technology. So there's a lot of companies, especially startups, working on nanosatellites to fulfill different functions of our everyday life without requiring the big launches to GEO. One of the things with nanosatellites, and perhaps you've heard about this, we're talking about also objects like the Starlink constellation and other constellations. They use small satellites in big amounts to make some kind of network on low orbit. And that allows them to cover big areas of the Earth's surface and provide the service that the satellite provides. This is one of the examples of where we're launching way more than we used to. Constellations weren't even a thing that we could think of for many years. And now it's in everyone's mind in this sector. And this takes us from one really condensed big technology in terms of a big satellite into perhaps 90 small independent satellites. And this change in what we are really launching is some of the things we have to adapt to, that we are still struggling to adapt. The second one is reusable launchers. This perhaps is the one most people heard of. And this is the thing, for example, SpaceX does really well. One of the ways of reducing the cost and make it more affordable for companies to go into space is making launches reusable. For a long time, we were using non-reusable rockets. That means that the cost of launching was very high. Now we're reusing launchers, and we're also looking at reusing the second phase, which is basically the one containing the payload. So if we reach that point where both parts of our launcher, so the upper stages and the boosters or the first stage, is reusable, we will only have to pay for the fuel. It will still be quite significant, but it will be basically a change in the order of magnitude or for launch costs, and that will mean that some technologies that currently are just not affordable because too expensive to launch, even if they make sense, they'll start making sense economically, and then we'll have new technologies in space. So this is one of the reasons there's many companies pushing for launchers, and why some of the reason that many of the new companies in new space are into launchers and space access. Finally, some of the new additive manufacturing, like 3D printing, metal 3D printing, as well as some of the 3D scan, 3D imaging, and some of the different additive manufacturing technologies have been developed in the past years for Earth-based industries are being transferred into space to cover different aspects of the demands we have for the sector, both for satellites but also for spaceflight, where we're able to create the different pieces we need. Perhaps we can make spare parts in space, and this has shifted also our mentality from having to take everything with us into starting to think about how to create things in space. This is also a shift in mentality that has occurred in the past years, and this is starting to explode. So let's really run through some of the big players currently. So one of the big players, it has been from the start and still is, are the agencies. These are not all the agencies in the world, but are some of the most important. So we would have ESA, which is the Chinese space agency. We have CNES, which is the French space agency. JAXA, which is the Japanese space agency. ESA, which is the European Space Agency. And for example, NASA, which everyone knows, which is the American Space Agency. All these agencies are publicly funded and normally have research in mind as well as space access in mind. This means that they're normally looking into doing research, science, advancing technology, or creating an environment that allows other companies to thrive and get space access. This is what many of them call incubators, where they're providing support both in terms of economical, but also technological, and in terms of science, to provide the companies with the boost they need to actually get to space. So they'll offer spaces to dock onto the ISS, new launchers like Space Rider that will have different autonomous experiments on board. They will offer expert advice. They will offer counseling for the companies. They will offer funding. So it's not only the missions completely done by the agencies, but also their collaboration with the space private sector that is giving them a new role, where they've come from being the only agents in this sector into basically the guides for the new ones for the private sector, so that they can actually reach their goals. Second one is the private sector. So these are three big companies in the private sector, but there's many more. For example, Blue Origin, SpaceX are some of the biggest private launchers currently. SpaceX, for example, launches many of the NASA payloads nowadays. Airbus Defense and Space is one of the biggest manufacturers of satellites, for example. We also have Thales Aliena, but also we have smaller companies, normal startups, that are also looking into doing normally nanosatellites. It's foolish to try to mention everyone in this slide. So what you have to get here is that these are companies that, instead of trying to basically reach their goal, they have to reach their goal with a profit. And this really shifts how they look at technology. They won't do a mission they are not confident they will get money out of. And that really shifts what they're trying to do. That is why it's important that we have the agencies basically pushing for those technologies that are still not profitable, so that these kind of companies can then make use of them when they get to that technology readiness level, that they can actually make it into a product, which in the end benefits everyone because it advances the whole sector. Then, as I said, there's some startups and especially research, private research, that are collaborating normally with agencies. So, for example, we have Aerospace Lab, Spring Institute in the middle, or Melissa. The first two are some startups. The third one is a research group that is founded by ESA, but has many universities involved and collaborating. These three in particular are looking into spaceflight and how to make spaceflight sustainable for humans. But there's many other kind of startups looking into the different aspects of space, which in general are launchers, satellites, and the rest, especially spaceflight. But in general, we're talking here about companies that are working normally using grants and using public funding to advance some further knowledge in the space sector so that it can become eventually a viable product, or that it can allow for example, longer missions on space, allowing thus for more research. Finally, and perhaps more interesting for some of the people attending today or, for example, in the future, is what it can offer to students and universities. So one of the most important things, especially in Europe, is the effort being made to involve people in the space sector as soon as possible. This means that there's a big effort made to give access to students to space. For example, ESA Academy, CANES, they have different programs like Patriot program or the Zero G Flight program, where they're offering different platforms for experiments to be sent to space, operate in space just as any other, and provide results. This has two big benefits. On one side, we're able to harness a lot of the creativity and drive of very motivated students that are eager to collaborate in this sector. On the other hand, these students get a lot of experience that will allow them to basically head start their career in the space sector by already having a lot of experience into how this works, and thus allowing the space sector to grow even faster, especially when we start having feedback loops where the people that were in these kind of projects know what's been done in those projects and thus can really value what new people coming from student university projects can offer. For example, I was honored, or I had the privilege of, for example, being part of IEM, which was a student project that actually got to the International Space Station, and it allowed more than 30 different engineers to get experience with a really real, completely serious space experiment, and thus gave experience that normally you wouldn't get until you get hired by a space company, which is unfortunately not really easy, because even if there's a shift, it's not as prevalent as some of the other industries. So it's important to understand that the university period is a big opportunity to get a head start, especially if you're interested in these kind of sectors where agencies and public funding can really give you that boost, that access, that privileged access to the sector. And it's really an opportunity for anyone who would like to be in the space sector to just make use of it and get to space as early as possible. And that's basically it. I'll be happy to take any question if there is any. And I would also like to thank the Google Developer Group of Valladolid for inviting me today to speak with you, and I hope you found it interesting.
So great. Good talk. I don't think. No, there isn't any questions in the chat. So if you have any question, now is the time. Have a few minutes left. So thank you very much, Jorge, for this
My pleasure.
amazing talk. Space is always a very beautiful theme. I love space. I mean, I have my Doctor Who poster right behind me. So yes, I love space. And so there isn't any questions. So let me make you a little question. Could you give us software engineers a bit of advice of how to get into this new era of space?
For sure, for sure. So actually, it's good that you asked that, because there's actually a true demand for software engineers in the space sector. There's actually a lot of aerospace engineers currently doing software engineer work, because there is a huge demand for IT development for the different startups, especially. You have to take into account there's a lot of things that have to be automatic in a space payload. Normally, we're talking about things that are not manned, they're not piloted. So they have to operate on their own in space. So it's all relying on software operating correctly, both to activate the different parts of the payload, but also to communicate. So one of the things that can be done here is basically there is a lot of startups, especially in Europe, that are always looking for new software engineers and IT specialists to get into the sector. One of the perhaps good things about space sector is that it's a very broad subject. It's not the same as, for example, chemical engineering, where we're just talking about chemistry really applied to engineering. Here it's space engineering, where all the engineerings that we currently have on Earth are just transferred to space. That means it's not only aerospace that gets to go to space. We have industrial engineers, we have mechanical engineers, we have telecom, we have aerospace, we have software engineers. So my advice would be to both look into the different projects that there are with ESA, especially ESA Academy, but also CNES and some of the other European space agencies, if you're still a student or you're not looking for work. And if you're looking for, let's say, employment, then I would say look into the different startups currently sprouting all throughout Europe. There is a lot in Spain, for example, also in France, Germany, England, well, in most countries, Italy. But in definitive, I would say, or in summary, I would say just try to search for the startup that really resonates with your ideas. And normally there will be space for IT. And try your best. And normally there will be some positive response. And yeah, there's also some groups that will give students and new engineers different, basically, contacts in the, I'll say this, in the sector. So joining those groups, they change from country to country, but they're normally really accessible through LinkedIn and other platforms. They will be really happy to show everyone or aim them towards their goals. So I guess that would be my answer.
Okay. Thank you. Thank you. So we have a couple of questions in the chat.
Sure.
First, well, following the line of my last question, Mara says, I was wondering, how do you think the AI will impact in this field?
Well, that's a really good question. It really depends on perhaps what application of AI we're talking about here. I think AI is going to impact engineering as a whole in a big manner. It's already a big part of how we do engineering, at least in aerospace and industrial engineering. There is a lot of solvers for many of the design softwares that make use of AI to both perhaps make layouts or preemptively make layouts, but also to make designs more optimized. So AI has already been used. I think it's going to impact a lot in the same way it's going to impact normal engineering currently on Earth, in the sense that the moment that software engineers really become proficient in using AI as an enhancer of their abilities, well, it will impact also the space sector because we're using IT. I don't think it will impact the space sector particularly, in the sense that the kind of things that change in space aren't really impacted by AI. So microgravity doesn't really care about AI, but it will impact in the sense that as normal technology advances, it will definitely be translated to space almost immediately.
Great. So one last question from Manuel. Which materials are the most cost effective when mining asteroids or other planets?
Well, I mean, that's a good question. It's a bit of an hypothetical, I guess. It depends a lot on how we get there, and by what means and by what time. So currently, some of the most cost-effective would be some of the metals that are really, really rare on Earth, and we normally only get from asteroids. So if we manage to get one of those asteroids, we can get some of the rare metals, rare earths, in big quantities, and that, with the current prices, will make it very valuable. If we go a bit more sci-fi, There is a big argument that materials like helium-3 that can be found in different celestial bodies can be a big part of fusion energy in the future. So many people believe that can be some of the most important resources to be mined outside of Earth, where it's very rare. But for example, Moon and also Mars is thought to have helium-3, and that can be a big part of how we basically how the paradigm shifts in terms of what's the new fuel of the future. But yeah, I mean, currently I would say that it's the rare metals that we can find in the different asteroids. In practicality, we can find more, for example, iron in some of the asteroids that we have on the whole crust of Earth, which would basically upheal the whole market if we get one of those. But it really depends on how we're mining those asteroids, because some of the metals perhaps are not worth extracting. So it really depends on when are we talking about, basically.
Okay. So no more questions, I think. Last call for for the questions. Well, if there aren't any more questions, thanks a lot. Manu says thanks a lot.
You're welcome.
So I think this is it. Thank you very much for your time and for sharing your experience and your knowledge. Uh, as I said before, very interesting. It's very interesting right now, the new era of space. Uh, so I think I'm gonna end this live. Well, before I end, I finish the live. I would like to say goodbye because this is my last event as a GDC lead of Valladolid. Of course, I will continue as a GDG organizer, but as a GDC lead, this is my last event. So thank you everyone for these 2 years. Thank you, Mara, Manu, Marco, Dani, Miguel, Juanjo, Adrián. I don't think I leave anyone behind. Cocho, Pablo, etc., etc. Sergio, of course, our community manager. Thank you for these 2 wonderful years, and I can't wait to see what the next leader can give to the GDC Valladolid. Well, thank you everyone. Of course, thank you Jorge for the talk again.
My pleasure.
Well, let's say bye bye to everyone, and see you soon.
Yeah. See you soon. Okay. Bye bye, everyone.
Bye bye.